Okay, now that the assembling is done, let's see what happens if we try to run this now. We still completely broke it. One of the comments from last week's video was I should actually give a demonstration of using Flex, and I have something that I can actually demonstrate, actually doing something useful with it. I am working on building a collection of utilities which are customized for the color computer version of Flex, and I'm actually going to demonstrate that process. So let's get started. Okay, I am using XRoar. This is going to be the best emulator for running Flex. I could also do this on real hardware, but the recording quality will be better if I do it here in OBS. I have my Flex master disk here. This is actually a cut disk that I've made for doing software development. Let me just start this up with run Flex. This will take a moment to load. There we are. Flex always starts up and has a date prompt. Today is May 18th, and the year is 2023, which of course, this thing is not completely Y2K compliant. I can't type 2023, but I can type 123. All right, so this is the startup screen. They just show a little example. So what I'm going to demonstrate, if I look at disk number 1 here, I have a source code file called dump.txt. And this is a program which I want to assemble. Before we get into assembling this, I do need to check one thing. Flex doesn't really have directories, but it does have a concept of working drive. So if programs open files, they will try to open them on the current working drive, or at least that's the default drive. So you can set the default drive for the system drive and the work drive. What I want to do is I want to set the work drive to be drive 1. That way, when I run the editor, it will actually look on drive 1 by default. Okay, so here is the source code. It is a dump utility. It basically displays a file on the disk. And we're not really going to go through this. Just wanted to show an example very quickly before we go on. Let's see if I can find the correct keys. Colon, no, colon should be here. Boy. I always get messed up when the keyboard is color computer mode. Okay. Let's assemble this. And now we actually see the assembler output going through the whole program. I am going to speed this up. And then I'm going to show you how to actually capture this particular listing. Right now, the listing is being sent to the screen. We can capture it to a file instead. Okay, it looks like the assembly is finished. It's dumping the symbol table. And if we take a look at what's on our drive 1, we had one file before, and now we have dump.bin. So let's go ahead and try running this and see how well it works. So this is a drive specification in Flex. You put the drive number, and then you put a dot, and then you put the file name. It actually doesn't matter whether it's uppercase or lowercase. Ah, I didn't tell it what file I want to dump. Let's dump dump.bin and see what this output looks like. So the first line, it tells us track 1, sector 9, and it's dumping all the data. You see that it has hex and ASCII, and if you notice, it's overflowing the screen. It doesn't actually fit on the screen because it's actually too wide. Let's just try as an experiment. I can also demonstrate another feature of FHL Flex. It actually has a 64 by 24 mode, and we want black text on a white screen. The screen that we were in before is a 51 column screen. So let's run this one more time and see what it looks like on a 64 column screen. We can see that it fits a lot better, but it's still kind of a double line. So still not quite what we want. I think what we want to do is there's a space in between every single hexadecimal character. I think we just want to knock that space out, and it should make this thing work a lot better. Let me go back to the 5124 BW. And I'll open up the editor. So take a moment. All right, so if I go down a couple of pages, loop read one sector. So point to line data, dump. Get a character, move parity. Okay, I'm trying to figure out what this program is doing. Output hex digit. And it outputs a space after. So what we said was we actually want to knock out this space right here. If I insert an asterisk, which I think is here, there we are. Comment out this line. and comment out this line here. And I actually want to go back up here. Want to insert a line here. Go to uppercase. I actually want to put a space in here. Okay, I think it's like this. Let's check if that was correct. Put char. Put chr, not out chr. Okay. I think it was put ch. R. Okay, we just wanted a space in between these two things, so that should work. All right, I've made the modifications that I want to make to dump.text. So how do we capture that assembly output? So what you can do in Flex is similar to what you can actually do in Unix, but it's a little bit different. We can use a program that's just called O, and this is the letter O. And this is an output redirect. So where do we want to redirect it? We want to redirect it to dump.listing. The command that we want to run is the assembler. And what do we want to assemble? We want to assemble the file we just edited, dump.text. So now if we run this, we will not see the assembler output on the screen. It's actually going to go to the file. Although it is very likely going to ask us a question, do you want to delete the old binary? Need to make sure to type a capital Y to all of these prompts, capital Y or capital N. You do not want to use lowercase. So it's going to reassemble it and replace the old binary with a new one. Then we can see what kind of a mess we made out of this program. Okay, let's see what we have on drive 1 now. Right, we have our listing. And we can actually take a look at that. Just basically want to make sure that there are no errors in what we did. Zero errors detected. So now let's try running it. That's interesting. Looks like it doesn't exactly work. What do we do? Oh yeah, I just figured out the what the bug is. If you look at the original code here, it events the pointer, and then instead of it events the pointer to the next character it wants to print, and then it prints the space. It loads the space character in the A register, and then actually jumping to a subroutine. The put character subroutine is a subroutine. At the end of it has RTS, which would return from the subroutine. So the bug is, what we actually need to add is return to subroutine. This was actually the entire problem with this, that we removed the RTS by commenting out this code over here. Now, I think that this push and pull up here should be completely unnecessary. We just delete this, and we delete this, and save it. And now we assemble it again. Okay, now that that's done, okay, this is fine, except there's one more tiny little bug we have to fix. We just have to put a space back in between the end of the hex and ASCII. So let's go ahead and do that. Right here, I think. Okay, I think that looks good. Save this and assemble it. All right, let's see if the third time is the charm. Yep, looks like it is. Let's go ahead and look at a text file. We can look at the listing. Yep, looks like that's working. Okay, so that was my little demonstration of doing a little work in Flex using the bed editor and the TSC assembler. Oh yeah, There's one more thing we need to do. The assembler outputs things with the extension of bin. The normal command extension for commands that you run is cmd. So go. Yep, that's it. Alright, so this is what I wanted to show you today. I think the next video will be what I had originally planned. I'm actually going to show the entire process of how I got this working. It required some work with the disk images to get them in a format where they will even work at all. So I wanted to explain that one. Alright, bye everyone.